Hey everyone, today we're going to cover 12.7, which is called Dilations. And then on Wednesday, be looking for a quiz review just on sections 12.5 and 12.7, so symmetry and dilations. And then plan on the next quiz being on Monday, May 4th. Same as in the past, it'll be open all day from 8 a.m. till midnight. Make sure you take it between those hours. And I think it'll still be open for 90 minutes. It should not take very long at all. Just to keep make sure everyone's on the same page here. There are some things there's some settings in there that can alert me for dishonesty and cheating, and please just follow the directions. You're allowed to use your notes. You're allowed to use your homework. You're even allowed to use the quiz review. Just don't talk to each other and be honest about that. I'm trusting you guys will do that and follow directions. This stuff is not too bad. So if you follow along, you should be in good shape. And if you are confused, email me and we can work through that. All right, so let's go over the 12.5 homework first. 3, 4, and 5, tell whether each figure has line symmetry. If so, copy the shape and draw all the lines of symmetry. So for number 3, these pink lines here are the lines of symmetry. It has 2 of them. Number 4, the butterfly has 1 line of symmetry. And number 5, there were no lines of symmetry. If you were to try to draw on a line of symmetry, this part here does not match. If you were to fold the paper over to here, they would not match up. And same if you drew a line this way. All right, so for number 6, yes, and the order was 2, and that means the order or the angle of rotational symmetry would have been 180. For number 7, no rotational symmetry. If you were to rotate this 90, nope. 180 to be upside down, 270, nope, and then back to 360. So no rotational symmetry for 7. For number 8, it's a yes. The order would be 3, so it means each one of them is 120 degrees. Again, if you're struggling with this, put 1 point there, and imagine what it would take to get that to match up with this picture. And you'd see that point would take to get down to here for the first time this picture would be identical, and then this would be the second time. And so back to the beginning would be the third time, which makes the angle of rotational symmetry 120 degrees. 13 was yes. 14, yes, and then had 3 lines of symmetry. And 15 was no. All right, so a dilation is a transformation that changes the size but not the shape. Size but not shape. The pre-image and the image are similar after the dilation. Remember that word similar back earlier? Similar triangles have the same shape, different sizes. And so, again, the shape should not change, just the size. And so this rectangle, when it's dilated from the blue to the red, yes, and the image has not been turned or flipped. And this one, it's similar, like polygon. I mean, the shape, the number of sides and stuff is the same, but that's not what it's talking about. The this it's not even an enlarged version. It's totally kind of stretched in one direction, not others. So that would not be a dilation. And the way you do it on a graph is if there's always going to be a factor remember, is when you multiply. And so if you take the original point and multiply it by this number k, you multiply the x and the y by k. And so if your scale factor is 3, then you'd multiply this number times 3 and this number times 3. And what it does is it stretches it out to be 3 times further from the origin. So here's some examples of this. Go ahead and pause the video to graph this. It's the quadrilateral ABCD. And the points are, for the pre-image, are -4, 4, 2, 5, 5, -1, and -5, -4. And so this is the original, and then we're going to have a scale factor of 2. And so A prime with the scale factor of 2 we're going to multiply -4 times 2 and get -8, and then multiply 4 times 2 and get +8, and that's going to be our new dilated point A, and we call it A prime. So -8 would be right here, and that's going to be A prime. B prime, after a scale factor of 2, would be 4, 2 times 2, and then 5 times 2 would be 10. So 4, 10. So 1, 2, 3, 4, 10. For B prime, C prime would be 10, -2. 5 times 2 is 10. -1 times 2 is -2. So 10, -2. And then D prime would be -10, -8. -10, -8. So this was C prime over here, and D prime is way over here. And so when we connect that, make sure in your homework you're drawing the pre-image and the image. So A prime to B prime down to C prime, and then C prime down to D prime and then back up. Again, what you'll notice is every single one of the points has been stretched away from the origin by a certain amount. And so A prime is now at -8, and you'll notice its distance from the origin has just stretched out. And so we go from the origin, if you imagine a line to A, and then to A prime, it's now twice as far away because of the scale factor of 2. And so that same happens for B prime, for C prime, and for D prime. So it's always a dilation from the origin on the graph. Now you don't need to draw those blue lines in there. I'm just showing you how the stretching occurs. Remember, the word dilate is to either become larger or smaller. And in this example, the scale factor was 2. All right, let's do another one of those. This one's a little different. We've got a negative scale factor. This one, the scale factor is -1/2. Go ahead and pause the video. Graph this one. P is at -4, 4. Q is at -2, -2. And R is at 4, 0. So P prime, we're going to take -4 and +4 and multiply it by our scale factor. So -4 times -1/2 is going to be a +2. +4 times -1/2 is -2. So 2, -2 is where P prime is going to go. And then next, for Q prime, when you take -2 times -1/2, you get +1. So +1, +1 for Q prime. And then R prime. Four times -1/2 is -2, and then 0 times -1/2 is 0. So -2, 0 is where R prime is. So we connect these, P prime to Q prime to R prime back to P prime. Now, the weird thing about this one is, because it had a negative scale factor, here's the origin. If I were to draw a line to P, a negative scale factor means it gets reflected, and then it gets in the opposite direction. And then whatever its distance was from the origin up to P, it's now half of that distance just in the opposite direction. So this one's kind of weird to try to visualize before doing the math. That's why it's easiest to just multiply the x's and y's times the negative 1/2 first, graph them, and then you'll see what the dilation looks like. Here's one more example in case you needed an extra one. This is just for people who are still a little confused. This one, the scale factor was -2. So ABC is this blue graph over here. And if you multiply every x and y times -2, which they do in blue over here, I'm sorry, red. They do in red over here at this work. And then they show the results over here for A prime, B prime, and C prime. And when you graph it, you'll see the image there. All right, the last type of question you might see in the homework or on a quiz is how to find the scale factor. So what is the scale factor of a dilation centered at the origin that maps the point -2, 5 to the point 6, -15? And so in the last couple of examples, we took points, we called it like A, and then the new one we called A prime, and we multiplied A times a certain number to get A prime. And so this one's not so bad. We always called this scale factor K. So -2 times what gave us 6? Well, 2 times 3 would be 6. So -2 times -3 would be +6. So K must be -3. Let's double check it. Let's do the next. Let's do it for the y's and make sure. 5 times what gives us -15? Well, 5 times +3 is +15. So 5 times -3 would be -15. So yes, that scale factor of -3 would work. Now, sometimes these will be like 6 and -15 will be weird decimals. And so the way you could do it is if you think about if I take a number and multiply it by a number to get the ending result, then to find that number, I could have taken these and divided by the original to get the scale factor. So so A prime divided by the original gave me -3. The new y value, -15, divided by the original y value of 5 gave me -3. So if it's a weird number like a decimal or a fraction, that's the mathematical way to find the scale factor. You take the ending A prime value, divide them by their originals, and that will give you the scale factor. Just like when we did describing the effect on like the surface area or volume earlier in the year, we did new divided by original. Same idea here. Anytime you want to find an effect, you take the new divided by original, and that will give you the scale factor. All right, that's it for this lesson. There's the homework for you. Make sure you're graphing 9 through 12. I do check this. I do check to make sure you guys are following the directions completely for the homework. Really not giving you guys much to do there, so make sure you do it thoroughly and make sure you're submitting them on time. We need to kind of make sure we're keeping in that routine of staying on top of math every Monday and Wednesday and submitting it Tuesdays and Thursdays. You have 40 hours to complete one assignment, so stay on top of it, and it shouldn't be too bad. Email me if you have questions or concerns. And remember, Monday on May 4th will be your quiz, so please plan accordingly. Have a great day, and make sure you're following the directions for submitting your work. Have a great day.